So continuing with hydrogen, we are doing more questions of hydrogen. This is our lecture number 2. First question is, who discovered hydrogen? So hydrogen was discovered by Henry Cavendish, who named it as a hydrogen. Lavoisier was the man who named it as a hydrogen, which means a water producer. Then gave some atomic properties of hydrogen. It has very small size, it has high ionization energy, that is 1310 kilojoule per mole. Its electron affinity is 72.8, atomic radius is 37 picometer, and its ionic radius is 210 picometer. Then we have 4 question of hydrogen. Give 5 physical properties of hydrogen. Physical properties of hydrogens. It exists as a gas. It is a diatomic gas at room temperature. Second is its melting point is 13.8 Kelvin. Its boiling point is 20.7 Kelvin. Its density is 0.0899 gram per cubic centimeter. Its bond length is 77 picometer. Its covalent radius is 37 picometer, and its bond energy is 435.9 kilojoule per mole. Now we have another question. What are ortho and para dihydrogens? So orthohydrogen is that hydrogen whose nuclei spin, the nuclear spin of the two atoms of hydrogen molecule is in the same direction. That is called as the orthohydrogen. If the nuclear spin of the two hydrogen atoms of the H2 molecule it is in the opposite direction, then that hydrogen is called as parahydrogen. So nuclear spin in the same direction. And nuclear spin in opposite direction. These are called as ortho and para hydrogen molecules. Now what is Lales process? Question number 6 is, what is it? Involves preparation of hydrogen from water and iron. When red hot iron it is passed with steam, we get Fe3O4 plus 4 hydrogen gas molecules they are produced. So this is called as red hot iron. When it is steam is passed over red hot iron, we get hydrogen gas. This process of preparing hydrogen is called as Lales process. Then we have the next. Question number 7. Give Bosch process of preparing dihydrogen gas. In Bosch process, steam is passed over or water is passed over red hot coke, which reacts with the water to produce mixture of carbon monoxide and hydrogen. This mixture is called as water gas, and when it is reacted with more hydrogen, it will produce more. When it is reacted with more water, it will produce more hydrogen gas along with carbon dioxide gas. So now question number 7, what is Bosch process? So it involves the action of steam on the red hot coke to produce water gas. The action is this is also called as syngas. It is reacted with more water to give you CO2 plus 2H2. This reaction is second reaction is also called as hydrogen shift reaction. So this is called as hydrogen shift reaction. How do we separate hydrogen from water gas? It is separated as follows. So water gas treated with more water here in the presence of metal oxide Fe2O3, Cr2O3 at high temperature to give you CO2 plus 2H2. This reaction is also called as hydrogen shift reaction because here hydrogen is shifted from water to the hydrogen form, dihydrogen molecular state. Then we have, what do you mean by hardening of oils? What is hardening of oils? When hydrogen gas is passed through vegetable oils in the presence of nickel, it gives saturated fat or ghee. This is called as hardening of oils. We have vegetable oil. It is supplied with hydrogen in the presence of nickel at 470 Kelvin. We get vegetable ghee. This is hardened oil. That's why this reaction is called as hardening of oil. Then we have 10th question. Give uses of dihydrogen. Number one, it is used as a reducing agent. It is used in the preparation of ammonia by Haber's process. It is used in the hardening of oils, in the preparation of synthetic petrol, and it is used in the oxygen hydrogen torch for welding purposes. Liquid hydrogen oxygen, they are used as a fuels in rockets in the fuel cell, and it is used in the preparation of number of organic compounds through reduction of the one kind of compound or other kind of compound. Now what is atomic hydrogen? What is atomic hydrogen? It is prepared by passing hydrogen gas through electric arc. When electric arc is struck between the two tungsten metal filaments, the hydrogen molecule breaks up to give you atomic hydrogen. The temperature is around about 7 to 30 Kelvin. So we have H2 at 2230 Kelvin. It breaks up to give you hydrogen by in the electric arc between tungsten filament. Then hydrogen molecule breaks up to give you dihydrogen gas. So this is the preparation of dihydrogen gas. Then what is nascent hydrogen? How it is produced? Nascent hydrogen is a highly active form of hydrogen. It is produced by the action of active metals on the acids, inorganic acids like HCl, H2SO4. The nascent, the atomic hydrogen so produced that is used up in the reduction of the number of compounds. Question number 12 is, what is nascent hydrogen? How is it produced? Nascent hydrogen is produced by action of active metals like zinc, magnesium, iron, like zinc, magnesium, iron on the inorganic acids. Zn plus concentrated sulfuric acid, it will give you ZnSO4 plus 2 hydrogen. It is consumed by the organic compound already present in the vessel. If that is not present, it will change into gas. Then iron also produces nascent hydrogen first of all, which combines with the other active compounds during the reaction conditions. Then which hydrogen is the most reactive out of atomic hydrogen, molecular hydrogen and nascent hydrogen? It is the atomic hydrogen which is more reactive. Then is the term of nascent hydrogen, and in the last we have molecular hydrogen. So order of reactivity of the hydrogen. This is the order of reactivity of hydrogen. Then there is a question which is based upon the strength of the hydrogen peroxide. Calculate the strength in grams per liter of the molarity and normality of 40 volume of H2O2. Calculate strength of H2O2 40 volume H2O2 sample. Also give its molarity and normality. Now, what is 40 volume of H2O2? 40 volume of H2O2 means 1 liter of this sample will produce 40 liter of O2. Let us take a reaction. Let us take decomposition of H2O2. When H2O2 decomposes two molecules of weight, it produces 2 water and O2. Its weight is 68 gram here. So how much oxygen is produced here? 22.4 liters of oxygen is produced here. Now we will be following unitary method, that 22.4 liter of H2 is given by 68 gram of H2O2. 1 liter will be given by how much upon 22.4 liters, and 40 liter will be given by, it is multiplied by 40. So from here we will calculate the strength of the hydrogen peroxide in grams per liter. It comes out to be 1 to 1.42 gram per liter. Now to calculate molarity, it is present in 1 liter, so we divide it. To calculate molarity, divide this weight 1 to 1.42, divide with molecular mass of H2O2. This will be the molarity, or divide the weight with atomic equivalent weight of H2O2. Equivalent weight is 17, so 1 to 1.4 upon 17 here. So this will be the molarity and normality of this sample. It is, molarity will be 3.147. it is a number, no units are there. 3.57 is this value. Then we have the normality, it is 7.142. So in this manner we can calculate the molarity volume of different samples. Now there are the problems for you. Calculate strength, molarity, normality of 10 volume, 20 volume, 30 volume, 50 volume samples of O2. You have to calculate all these as we have calculated in case of 40 ml. Then 10 volume of H2O2 means 1 liter of this sample of H2O2 will produce 10 liter of O2 on decomposition. 20 volume means 1 liter of this sample on decomposition will produce 20 liter of the O2 gas. Similarly, 30 volume means 1 liter of this sample on decomposition will give you 30 liters of the H2O2. Similarly, in 50 volume means 1 liter of this sample will produce 50 liter of O2 gas. So in this manner we can calculate strength, normality and molarity of the any sample given to us. Now what do we mean by 20 volume of perhydrol? Perhydrol is other name of hydrogen peroxide. Now 20 volume of perhydrol or H2O2 means that 1 liter of this sample on decomposition will produce 20 liters of the H2 gas, 20 liter of the O2 gas. So by this reaction, the basis we can take the first reaction of decomposition of H2O2, 68 gram of it produces 22.4 liter. Then we will be following the unitary method. What is the volume available? So, in first calculation it will be put here 10, 20, 30, 50 and so on. In this manner the calculation will proceed. So this is our lecture 2 of dihydrogen.